Hello my dear students, let us start a new topic of software engineering, that is introduction to software engineering. Software engineering consists of two words, software and engineering. Software is nothing but collection of programs. It is just a program code. A program is an executable code which serves some computational purpose. Software is considered to be a collection of executable programming code, associated libraries and documentation. Software when made for a specific requirement is called a software product. That means software is nothing but a collection of lines, programming lines. What is a program? Program means it is an executable code which is generally used for computational purpose. Software is considered to be a collection of executable programming code, associated libraries and documentation. That means software consists of some programming code. Programming code means number of lines that may be written in C, C++, Java, .NET or PHP, any type of programming language, some associated libraries and documentation. Documentation means software requirement specification. That means whenever you develop the software, you maintain one document for that software. For maintaining the document, you need some tools and technique that will be discussed in the future topic. Software when made for a specific requirement. Let us consider we can develop a software for banking project. So that software is known as banking software product. For example, whenever we develop a software for railway project management, that is known as railway software product. And software is nothing but it consists of some executable codes. Executable codes means number of lines present on the software. That lines means number of instructions given to the computer. Engineering on the other hand is all about developing product using well-defined scientific principles and methods. Engineering means it consists of some principle and some methods. By applying some principles and methods, we develop a software, so that it is known as software engineering. So we can define software engineering is an engineering branch associated with the development of software product using well-defined scientific principle, methods and procedures. For developing a software, we maintain some scientific principle, we maintain some methods and we follow some procedures. The outcome of software engineering is an efficient and reliable software product. Whenever we develop the software by applying some principle methods, the result is always a efficient and reliable software product. Efficient means that is very good software. Reliable means the software is very hard to break. We can discuss the reliability of software in the future classes. What is generally IEEE? IEEE defines the software engineering as the application of a systematic, disciplined, quantifiable approach to the development, operation and maintenance of software. For creating the software, we can maintain the software, we can develop the software in a very beautiful approach. So this is known as the definition of IEEE. IEEE gives the definition of software engineering in this manner: the disciplined, quantifiable approach to the development, operation and maintenance of a software. Then software engineering principle use two important techniques. The techniques are known as abstractions and decomposition. For developing software, we can manage abstraction principle and decomposition principle. What is generally abstraction? Abstraction means omitting irrelevant details. Irrelevant details means the things which are not important to the user, we can omit that details from the user. That is known as my abstraction principle. Abstraction means show the functionality and hide the complexity. We can hide the complexity from the customer. This is known as my abstraction. In other words, the main purpose of abstraction is to consider only those aspects of the problem that are relevant for certain purpose and suppress other aspects that are not relevant for the given purpose. The things which are very important that can show to the user and those are not important, we can suppress from the user. That is known as my abstraction. Once the simpler problem is solved, then the omitted details can be taken into consideration to solve the next level of abstraction, and so on. Abstraction is a powerful way of reducing the complexity of the problem. The other approach to tackle problem complexity is decomposition. Second principle is decomposition. What is generally decomposition? Decomposition means dividing the complex problem into smaller subproblems. We can divide the complex problem into small problems so that the problem can be solved in an easy way. That is known as decomposition. So for developing one software, two things make consider. First one is known as abstraction, second one is known as my decomposition. Abstraction means show the functionality and hide the complexity. Decomposition means bigger problem can be divided into small problems that can be solved easily by one person. Whenever there is some problem, there is some error in your code, programming code, so that we can divide, so that finding the error must be easy. However, in this technique, any random decomposition of a problem into smaller part will not help. The problem has to be decomposed such that each component of the decomposed problem can be solved independently, and then the solution of different components can be combined to get the full solution. First, we can divide the problem into small problems and solve these problems. After solving this problem, we can combine to get the full solution. This is known as top-down or bottom-up approach in your programming principle. A good decomposition of a problem should minimize interaction among various components. Decomposition, what is good decomposition? Good decomposition means we can minimize various components and combine the various components of a bigger problem, solve it separately, and after solving we can combine all these problems. If the different subcomponents are interrelated, then the different components can be solved separately and the desired reduction in complexity will not be realized. If the components are related to each other, then solving the problems becomes easy, and complexity, we cannot realize the complexity. So this is known as my introduction of software engineering. What is the aim to study the software engineering? Software engineering aim is to know how to develop the software. What are the different steps for developing the software? What are the different risk factor while developing the software? What are the different testing needs for developing the software? What is generally reliability? What is generally the risk factor while developing the software? How the risk can be handled while developing the software, and how many number of people generally involved developing the software, and it is generally taken in person in month. We will discuss in different types of models like COCOMO model. Different types of models are present. So software engineering means how to develop the software and what are the different components for developing the software. And the main two principles are abstraction and decomposition. Abstraction means just show the functionality, hide the complexity from the user. That means which functionality are not needed to the user, that functionality should be hide from the user. Decomposition means bigger problem can be divided into small problems so that finding errors becomes easy. Okay, so this is known as introduction to software engineering. Then what is the need of software engineering? The need of software engineering arises because of higher rate of change in user requirement and environment on which the software is working. See, why we can study software engineering, or what is the need of software engineering? Generally, when we develop a software, that software regularly requires some maintenance. Maintenance means always user needs more and more. More and more means more and more new features. So whenever there is some change in the user requirement, so suppose user wants some new things, suppose user wants some new features in your software, so how the software can be maintained and how the environment can be changed, how the environment will cooperate with the software. So this is the need of software engineering. What are the different factors? First one is known as large software. It is easier to build a wall than to house or building. Likewise, as the size of a software becomes large, engineering has to step to give a scientific process. So whenever we develop a large software, software engineers can adopt different procedure for developing the software. Scalability. If the software process were not based on scientific and engineering concept, it would be easier to recreate new software than to scale an existing one. If the software does not follow scientific and engineering principle, so when we can create newer software. Okay, then third one is known as my cost. As hardware industry has shown its skill and huge manufacturing has lowered down the price of computer and electronic hardware, but the cost of software remains high if the proper process is not adopted. Still, computer and electronics hardware becomes low price, but the software is remain high price. Dynamic nature. The always growing and adapting nature of software hugely depends upon the environment in which the user works. If the nature of software is always changing, new enhancement need to be done in the existing one. This is where software engineering plays a good role. What is dynamic nature of software? Now, software always change time to time. Whatever the first point we have discussed, software always require higher rate of change in user requirement. So dynamic means which is change time to time. Static means which is always fixed. So software is always in dynamic nature. Always the user requirement is changes. So according to the user requirement, the software must be changed from time to time. So dynamic nature of software. Quality management. Better process of software development provides better quality software product. Always software must be in quality. For maintaining the quality, there is some standards are there, that is known as ISO standard, International Standard Organization, or CMMI standard, Capability Maturity Model standard. We will discuss all these things in quality of software in your later on chapter. So whenever we develop the software, we must maintain the quality and we must follow the rule and regulation that is present in the ISO standard. There are different ISO standards are there: ISO 9001, ISO 9002, ISO 9003. ISO 9003 is generally used for your software industry. Then the next is what is characteristics of a software. Characteristics of a good software. Characteristics of a good software means a software must be operational, transitional, and maintenance. Operational means this tells us how well software works in operation. It can be measured on budget, usability, efficiency, correctness, functionality, dependability, security, and safety. All these things are present under operational. Budget means the software must be developed within the budget that was discussed in your feasibility study phase. We will discuss what are the different steps different steps of developing the software. Budget means always the software must be developed in budget. Okay. Usability means the software is usable by all the users, or the software must be adopted by many peoples. That is known as my usability. What is efficiency? Efficiency means the software is efficient. Efficient manner means working in a proper way. Correctness, the efficiency and correctness are slightly very much same, but what is the difference? Correctness means the software always works in a right path. Right path means whenever I will give some input according to the user requirement, the output must be there. That is known as my correctness. Next is functionality, dependability, security, and safety. Security means the software must be secure. Software must be secure means any outside person cannot crash your software. Let us consider, for example, you are developing a software for banking industry, so that any outside people cannot corrupt your data. That is known as my security. Dependability means how the software will depend on the platform. Platform means generally it is operating system or hardware. Okay. Then safety. What is the safety? Safety means the software is safe from your outside world. Next one is transitional. The aspect is important when the software is moved from one platform to another platform. That is known as portability, interoperability, reusability, adaptability. Portability means transferable. The software can be run on any platform. Any platform means any operating system, any processor. You must develop a software that is used in any operating system, in any processor. Okay, so this is known as my portable. What is interoperability? Interoperability means it can operate in any platform. Reusability means the software can be reused in different platforms and adopted by all the peoples. Then maintenance, the aspect, it briefs about how well a software has the capability to maintain itself in the ever-changing environment. Modularity, maintainability, flexibility, scalability. We will discuss the maintenance chapter in your future topic. But remember, these are known as my characteristics of your software. Characteristics of a good software. First one is known as operational, transitional, maintenance. Okay, these are known as my characteristics of a good software. Okay, so till now we will discuss what is the software engineering, what is the requirement of software engineering, what are the characteristics of a software engineering. Then the most important thing is software development life cycle, or you can tell that SDLC model. SDLC models means how we can develop a software. What are the different steps needed for developing the software? A software life cycle model is a descriptive and diagrammatic representation of the software life cycle. SDLC means it is the diagrammatic representation of a software life cycle. How to develop a software? Okay, we can represent it diagrammatic manner. A life cycle model represents all the activities required to make a software product transit through its life cycle phases. Transit means transfer from one stage to another stage. It also captures the order in which these activities are to be undertaken. In other words, a life cycle model maps the different activities performed on a software product from its inception to retirement. Different life cycle models may map the basic development activities to phase in different ways. Thus, no matter which life cycle model is followed, the basic activities are included in all life cycle models So the activities may be carried out in different orders in different life cycle model. During any life cycle phase, more than one activity may also be carried out. That means there are different life cycle models are present. Let us consider classical waterfall model, iterative waterfall model, incremental model, prototype model, spiral model. Which life cycle model you can follow, the steps are almost same. Let us consider the different steps are requirement analysis, feasibility study, analysis, design, coding, testing, maintenance. These are the different life cycle models of your software. Okay. What is the need for a software life cycle model? The need is whenever we can develop a software, the development team must follow the life cycle. The development team must identify a suitable life cycle model for the particular project and then adhere to it. Without using of a particular life cycle model, the development of a software produce would not be in a systematic and disciplined manner. If you do not follow any life cycle model, then we cannot develop the software in an efficient way.